Good day, students. Welcome to part one of the limit series on L'Hopital's rule. In this clip, we're going to be going over the indeterminate limit of the form infinity minus infinity. Okay, so let's go ahead and consider the following example. All right, so we're going to be finding the limit. So let's write this down. So example one, find the limit as x approaches 1 of 1 over the natural logarithm of x minus 1 over x minus 1. Okay? All right, so to calculate this limit, you notice that there are discontinuities in these two cases because the natural logarithm of 1 is 0, so we have a discontinuity here, and then 1 minus 1 is 0, have a discontinuity here. So what we're going to have to do is we're going to do the double-sided limit consideration of this ratio. Okay? All right. So let's go ahead and do the left-handed limit first. So we're going to approach 1 from the left direction. So left direction. Okay. So for this one, we're going to evaluate the limit as x approaches 1 from the left. So we're approaching 1 from the left of 1 over the natural logarithm of x minus 1 over x minus 1. Okay? All right, so let's go ahead and evaluate this. So we're going to have 1 over, just plugging 1 from the left in both of the x's here, the natural logarithm of 1 from the left minus 1 over 1 from the left minus 1. Okay? So this basically becomes 1 over. Now, what is the natural logarithm of 1 from the left? Or a number really close to 1 from the left. If you get really close to 1 from the left, what is the natural logarithm of that function? Well, let's take a look at what the graph looks like. So make a sketch. You notice that the natural logarithm function looks something like this. I always like to use my graphs to determine the directional limits, and this is 1. So as x is approaching 1 from the left, you notice that y is getting really close to a very small positive number. Okay? So the natural logarithm of 1 from the left is a very small negative number, I meant to say. So a very small negative number. Okay? Minus 1 over. Now 1 minus 1 from the left is a very small negative number. So another way we can express this, what is a really small negative number? It can be rewritten as 1 over negative infinity. Okay? 1 over negative infinity minus, in this case, the same story here, 1 over negative infinity. All right, so if I reciprocate this 2, multiply the numerator by the reciprocal of the denominator, I'm going to have 1 times negative infinity minus 1 times negative infinity. Okay? You can put this over 1 over 1. So what I did is I reciprocated this denominator and multiplied it by the top. So we're going to have minus infinity minus negative infinity, which comes out to negative infinity plus infinity, or you can write this as infinity minus infinity. So you can see approaching from the left direction, we have a result of the form infinity minus infinity. This is an indeterminate form. Okay? All right, so let's go ahead and approach from the right and see what happens. All right, so we're going to approach 1 from the right direction, and see what we get. Right direction. All right, so what we're evaluating here is a limit as x approaches 1 from the right of 1 over the natural logarithm of x minus 1 over x minus 1. Okay? Now, this represents the number that's really close to 1 from the right, like 0.0001, really close to 1 from the right, okay? We're going to plug that in here. We're going to have 1 over the natural logarithm of 1 from the right minus 1 over 1 from the right minus 1, okay? All right, like I showed you on the graph before, if we're approaching 1 from the right, the y value approach is a very small positive number. Okay, so this will be 1 over 0 from the right minus, in this case, also if we subtract these two, we're going to have 0 from the right. Okay, so 1 over a really, really small positive number, this really, really small positive number can be written as 1 over infinity. Okay, minus, this also can be written as 1 over infinity. So if we multiply the numerator by the reciprocal of the denominator, we're going to end up with infinity minus infinity. So you can see that in both cases, the limit is infinity minus infinity. So we can conclude that the limit as x approaches 1 from both sides of 1 over natural logarithm of x minus 1 over x minus 1 is infinity minus infinity. Okay, this is an indeterminate form, so what we have to do is we have to use the L'Hopital's rule. Okay, anytime you have an indeterminate form, the limit, if it can be expressed in a quotient form, so basically we can use this idea and write it in green. The limit as x approaches a of f of x over g of x is the same thing as the limit as x approaches a of f prime of x, the derivative of the top, or the numerator function over the denominator over the derivative of the denominator. Okay. So first thing we want to do is can we express this as a quotient of two functions, and then we can apply L'Hopital's rule. So let's see if we can do that. So what we can simply do here is find the LCD and combine the two fractions. Okay. So limit as x approaches 1 of 1 over natural logarithm of x minus 1 over x minus 1. So the LCD is ln x times x minus 1. So I'll multiply the right side by natural logarithm of x, top and bottom. And then this side I'll multiply by x minus 1, top and bottom, so I can find the LCD. And that basically makes my problem become the limit as x approaches 1 of x minus 1 minus, if I multiply these two, the natural logarithm of x divided by the LCD, which is the natural logarithm of x times x minus 1. Okay? All right, let's go ahead and evaluate the limit of this combined fraction that we just created and see if we end up with an indeterminate form. If we plug in 1 into this, it's going to become 1 minus 1 minus the natural logarithm of 1 over the natural logarithm of 1 times 1 minus 1. Okay, so this is going to give us 0 minus 0 over 0. Okay, so we have an indeterminate form again of the form 0 minus 0 divided by 0. Alright, so we have to apply L'Hopital's rule here. So let's apply L'Hopital's rule here. This limit is the same thing as the limit as x approaches 1 of the derivative d dx of the numerator x minus 1 minus the natural logarithm of x divided by the derivative of the denominator, which is the natural logarithm of x times x minus 1. Okay? Alright, so let's go ahead and differentiate and take the limit and see what we have. Okay? So if we differentiate the top, we're going to have 1 minus 0. The derivative of ln x is 1 over x divided by, in the denominator, we're going to use the product rule. Okay? So this is u and this is v. So the derivative of uv using the product rule is u. V prime is just 1 plus v x minus 1 u prime is 1 over x times 1 over x. Okay? Alright, now what we're going to do next is we're going to, I'm going to combine the fraction and the numerator. If I do that, let me write it first. I'm going to have 1 minus 1 over x on top over the natural logarithm of x plus x minus 1 over x. Okay? Alright, so there are two ways I can do this. Let me multiply the numerator and the denominator by x. Okay? So let me combine the fractions first. If I multiply by x, you get rid of the denominators. But let me just show you a different way of doing it. All right. So we have 1 minus 1 over x. So I want to make this a common denominator, right? So I times this by x top and bottom. So I can combine the two fractions, times it by x. And then this one I times by x also. Put this over 1. So the problem basically becomes um, x minus 1 over x, I combine the fraction on the top, divided by x times the natural logarithm of x plus x minus 1 over x, combining the fractions on the denominator, in the denominator, okay? So let's simplify this. I can simplify this by multiplying the top and bottom by x, and this becomes, I drop my limit, let me put the limit symbol back. The limit as x approaches 1, this x divides out with that, x minus 1 in the numerator, divided by, in the denominator, this x is divide out, x ln x plus x minus 1, okay? So let's see. I'm going to substitute the limit, the value of the limit, which is 1, in here, and see if I end up with an indeterminate form. If I do, I will keep on using the L'Hopital's rule until I get a form that's conclusive, okay? So if I plug in 1 here, I'm going to end up with 1 minus 1 over 1 times the natural logarithm of 1 plus 1 minus 1. Like, you're going to have 0 in the numerator. In the denominator, I'll have 0 plus 0, which is 0 over 0, indeterminate form again. So we have to apply L'Hopital's rule again. So this limit is the same thing as the limit as x approaches 1 of the derivative of x minus 1 over the derivative of the denominator, which is x ln x plus x minus 1. Okay? If I differentiate the top, I'm going to end up with 1. Okay, so let's put the limit there. The limit as x approaches 1. The numerator is just 1. 1 over, and in the denominator, I'll apply the product rule to this right here. This is u, and this is v. So if I apply the product rule, I'm going to have u v prime, the derivative of ln x is 1 over x, plus v ln x, u prime is just 1. And then the derivative of x is 1 plus 1. And then the derivative of 1 is 0. Okay? Alright, so let's simplify this further. We're going to have the limit as x approaches 1 of 1 divided by, this one's divide out. So we have 1 plus the natural logarithm of x plus 1. I can combine these two ones, so this becomes the limit as x approaches 1 of 1 over the natural logarithm of x plus 2. Now I can plug in 1 and see what happens. Okay, so if I substitute 1, I'm going to get 1 over the natural logarithm of 1 plus 2. And you're going to have 1 over 0 plus 2, which is 1/2. Okay, so that's the value of the limit. So the limit as x approaches 1 of 1 over the natural logarithm of x minus 1 over x minus 1 equals 1/2. Okay? So there you have it. So thanks so much for taking the time to watch this clip. Please feel free to subscribe to my channel by clicking up here. If you like this video, you can click like down here. And please post a comment. Tell me what you think. More videos can be found on my.serve.com. Thanks again and have a wonderful day.